Please note that these are good. Now you can see it. Now, good afternoon, everybody, dear students. Now, I just want to repeat this. This is more about you than anybody else. Meaning, as I've said before, if there is anything, you don't have to wait for anybody to ask you, is there anything? No. If there is something on the board that you can't see properly, please raise it. If there is something that I've said that you don't understand, raise it. I will try to clarify it using different techniques and whatever. Don't forget that I'm an old teacher. Ne? I've got teaching aids with me here, and then surely they will do their job. Okay, let us get straight into it. Today's topic, as you all know, is the volume of solids of revolutions. Now, back day, grade whatever, grade 10, grade 11, grade 12, you were dealing with volumes of those standard geometrical objects like a box. What is the volume of a cylinder? You know them. And obviously, we know the resulting answer. It cannot simply say is 3. Is 3 what? 3 centimeters or 3 liters. No, you need to include the unit properly. Otherwise, then you run the risk of being penalized, unnecessary. So that is my warning to you. Okay. Now, what is the formula for the volume of a box? Let us start there with those standard geometrical, objects. What is the formula for the volume of a box? Anybody?
Base times height times width.
That's good. Now, this is a box. Don't forget, as I've said, I'm an old teacher. I will come with those teaching aids. This is a box. Now, if you are asked to find the volume, calculate to find the volume of this box. Now, what you need to do is what? Calculate, get the area of the base. The base. So the base is like a rectangle. So it's a rectangle. Then to find the area of the base of this box, it will now be this side. You can call it L. Now this side, you can call it B. Therefore, the base, it will be L times B. Then from there, you multiply it by the perpendicular height. So what is the height of this box? It will be from up to here. Therefore, the volume of this box, it will be this multiplied by this side, multiplied by this side. And that is why the final answer, it will be centimeters cube, because it will be 4 centimeters by 3 centimeters by 2 centimeters. Therefore, it will be 4 centimeter by 3 centimeter, but so on and so forth. Now, if you have got a cylinder like this, so it will not be the area of this base, and you can see that the base is circular. Then it will be what is the area of something circular. Then it will be pi r squared, where r we know is the radius. Somewhere here is the center. Then it will be r, meaning the distance from this to this, which is r. Then the area of this base, it will be pi r squared. Then you multiply it by the height of this, which is h. That is why the volume of a cylinder like this, it will be pi r squared, which is the area of the base multiplied by the perpendicular height. Now, we're now going to use that to extend it further. To what? To those now objects which are not standard like what we did last week, where we were looking at the area of those non-standard geometrical objects. So here it will be the volume of those non-standard geometrical objects. Hopefully that makes sense. Okay. Now, say you have this as the Cartesian plane. Then you are asked to do this, to say what? They say what? Remember, this is the question. They say, find the volume. I did not even write find here. Find the volume. Find the volume. Okay, okay. But before this, let us look at this. Before this, let us do this. Before this, let us do this. Let's take this region. Let's say this region where this is part of the equation y is equal to x squared, meaning the full graph y is equal to x squared. It will be something like this. The full graph is this. But now here, we are not going to use the full graph of y equal to x squared. Then from there, don't forget, again, before we go far, don't forget. Now from there, we say, let's take this line, which is part of whatever, say y is equal to 2. Meaning the full graph of y equal to 2, it will be this. That is a full graph of y equal to 2. And again, we take this line segment from here up to here. From here up to here. Which is just the part of this graph, x equal to 0. This from here to here is part of this. The curve x equal to 0, or simply the y-axis. So which region is enclosed by these three curves? It will be this region. Hopefully we are together. So this region here is now, this region is enclosed by what? By y equal to x squared. By what? By y equal to 2 and the y-axis. The y-axis, which is x. Hopefully that makes sense. So let us now take all this out, because we have now identified our region, which is the key in what we are going to do. We are going to tell you that there is this region which is enclosed by these curves. Hopefully that makes sense. Now from there, you take this region, you spin it, you rotate it by a line, vertical line or a horizontal line. You take this region, you don't take this curve. We're not taking this curve. We're not taking this curve. We're taking this plane, this everything here. We're taking everything here. Then you spin it by this line. Then you are going to get what is called a solid of revolution. Let us go through this again. You take this region. I wish it was possible. Take this region. It's like this. You can just take this out, take this out, take this out. Then you spin it. You spin it by this line. you spin it by this line, you are going to get a certain object. Can you visualize that object and tell us how it will look like? How will it look like? It will look like this. Hopefully you can see it. It will look like this, more or less this. Does it make sense? And once you can understand it, then you can run with whatever. You can determine, you can find a volume of any solid of revolution. It will give you something like this. It's a solid of revolution. In string language, in my area, we call it what? Topo. I'm not sure whether we are familiar with this. Topo, topo, topo. Does it make sense, Pudi? Puling, does it make sense? Yes, it does.
Yes, it does.
It makes sense.
Yes,
it makes sense. Now here, this thing is what is called a solid of revolution, which is formed by taking this region and spinning it by this straight line. And this straight line is what is going to we are saying here, and we say rotate this region. We're going to say rotate it by this line, which is this curve. Rotated by, let me just write it in blue, rotated by the y-axis. And you look at it as two. You look at it as two. You look at it as two. This, we have said, is going to be the center of your solid of revolution. And this center is still part of those curves that enclose your region. This center is still part of these curves, because this curve is enclosed by this, and this. And this, which forms part of those curves that enclose your region, is still the center. So when you rotate this region by a line that forms part of those curves that forms a region, it will give you something solid. There is no hole inside. There is no hole inside. Hopefully that makes sense. That is good. The formula now to find the volume of this solid formed this way, it will be generally, it will be this. Now, imagine it is, or let's go back. Like, say what? Like, let's say a bread, white or brown or whatever. You tell me, how many slices can you get from a bread? I'm not saying how many slices are there in a standard or standard slices are there. My question is, how many can you get? How many can you cut? How many can you cut, Lerado? Slices in a bread?
18.
Are you sure about my question? How many slices can you get? How many slices can you cut? How many slices can you cut, Andrew? Just think, man. How many slices can you get? Cole?
So it depends how sharp your knife is.
Come again?
Depends how sharp your knife is. You can cut as many as you like.
I'm not sure whether I agree with you, but I like your answer. That is, depends. Because you can cut what? Only two. Don't say half is not a slice. You can cut only two. Somebody can cut only 4. Somebody can cut 18 because somebody said 18. Yes, you can have 18. Somebody can cut what? 25. Somebody can cut what? 100. Somebody can cut 1,000. But some of those numbers, it will just be what? Theoretical. You see. We find that practically, as you said, depend on how or on the sharpness of your knife. You can find that the thickness of those slides, it will depend on how many you have there. So if you have this, now what you do here is you're going to go do what? Because it's secular, we are now going to cut those slices perpendicular to the center. When you cut perpendicular to the center. Why? So that they will all look the same. Like if you have a braid here, whatever, a braid here, then if you cut them vertical like this, depending on the thickness, depending on their number, depending on their thickness, they will all look similar. So, but now here, if you have this, the center is vertical. It says the first center here is a vertical line. But if you put it like this, the center is a horizontal line. So then if you have something like this, and then you cut, because the center is a vertical line, then you cut perpendicular to the center, which is the axis of rotation. It will be the center. We have taken it out. We are rotating by the x-axis, not by the y-axis. Therefore, the axis of rotation becomes the center of your solid of revolution. So if it is like this, then you are going to cut horizontally because the center is a vertical line. Then you cut horizontally. But if your region is enclosed by this, please, you stop us at any time. But if your region is enclosed by this, say this. What is this? It will be horizontal. It will be something like this. We know it. It will be something like this. Then from there, we say the region is enclosed by this, which is this, is enclosed by, say, x equal to 3, meaning it's a vertical line like this. And again, it's enclosed by the x-axis. Which region here? We are either talking about this region or the one below. Because this 3, which is this, it must be one of the boundaries. And then we have got x equal to 3, which must be one of the boundaries. Therefore, is this thing inside everything. But now we are adding another boundary where it says the x-axis. That means the x-axis must be one of the boundaries. Therefore, here we're talking about this one above or this one below. But it won't make any difference because you are going to spin it. So we're talking about, let's say we're talking about this region. And from there, that is not all. The question is, you are going to spin it by which line? That is, you are going to spin it by which vertical line or by which horizontal line. Say you are rotating it by what? By the x-axis. Hopefully this color is still visible. So then it means our center is part of the curves that forms or that enclose your region. So therefore, it will be a solid of revolution, a horizontal. It will be horizontal, not vertical, but horizontal. There from there, you cut your slices. How are you going to cut your slices? You must cut perpendicular to the center. So don't forget, this is the center. I'm not sure whether you can see me. This is the center, the axis of rotation, which is part of the boundaries of your region. So because you are going to spin it like this, no longer like this, but now this way. It will now be this way. No longer this way, but now this way. It will now, at the end, you are now going to get something like this. Something like this. Then how to cut? You must now cut perpendicular to the center. The center is horizontal, therefore you are going to cut vertically. So in that way, when you cut vertically like this, then you cut. As we have said, you cut and you cut. So now you are going to get what? What we call a disc. That is what we mean by a disc. You are going to get a disc because you let's say you cut. Remember, this is now solid. It's like this. Now you cut, then you take that thing out. You cut, then you take that thing out. That thing there is what is called a disc. Then the question now still remains, how many discs now can we get from here? It will be infinitely many. It will depend on the thickness of each. But they must have the same thickness. One mustn't have a thickness of 7. The other one have a thickness of 8, just like the slices of bread. And in such a way that all those slices, they have the same thickness. Now, with that in mind now, I'm telling you, then you can answer any question related to this topic. I'm telling you, you can answer any question related to this topic. Now, the formula, it will be this. We have got 2 approaches. Then it means we're going to have 2 formulas for calculating the volume of a solid of revolution. Now, if this one of cutting the disk, which will be a representative of all those infinitely many disk. The formula, it will be pi. Then you say the integral of what now? Then you look at your disk now and say, how do I get its thickness? So what will be the thickness of the disk? That will come from here. Your disk was cut like this. It was cut like this, horizontally perpendicular to this. So to calculate how thick is your disk, it will now be what? You will now determine this. You will now find this, measure this. Hopefully that makes sense. If you cut here, what will be its thickness? You will now have to measure this from here to here. And what is this? Measuring vertically like this. It will be y here minus y here. In other words, it will just be what? The difference between the values of y. So then you write dy, meaning dy is now the thickness of your disk. Hopefully that makes sense. Then from there, what now? Then it means everything here must be in terms of y, because this is dy. Therefore, you now plug in your limits. You say, okay, this region now that I'm spinning runs from where y is how much up to where y is how much? It runs from where y is how much up to where y is how much? It runs from where y here is 0. You write 0. Where y is 0. And this region, it will continue and continue until where y is how much? That is the last value of y here. Then you plug it in, we have said is 2. That is y equal to 2. We have said it is y equal to 2. Then from here, what is the integrand now? What do we integrate? It will simply now be what? It will simply be now the radius of your disk. What is the radius of your disk? It will now be the distance from here up to the center, which is now a horizontal distance. Hopefully that makes sense. The distance from here up to here, or the distance from here up to here, the distance from here up to here. Meaning it will now be what? The distance from here, that's right at the center. The distance from here, right at the center. But don't forget, this is vertical. The distance from here at the center up to the outer. But don't forget, this is like this. Meaning it will now be the distance from here up to the center. Meaning it will now be a horizontal distance from here up to here. It's a horizontal distance. Meaning it will now be x here minus x here. And what is x here? It will be x at any point here. X at any point, because it doesn't matter whether you cut here or you cut here or you cut here or you cut here. The fact is you are cutting from this. Meaning you must now come here and make x the subject of the formula. X at any point here, x at any point here, it will be x equal to the square root of y. You can't say x equal to minus. So then from here to here is now the square root of y. And now from that formula of r squared, pi r squared, I'm going to say this now, then you square it. That is, square it. Then from there you are done. Then from there you integrate this. But don't forget, it must be from here up to the center. And then this, there is no hole inside. Then from there you integrate this. Any question? Then from here, everybody, including myself, I can now integrate this because it will just be this, the integral here. Now from there you get an answer because it will be the square root of y squared, which is just y. Then you integrate this, then you get an answer. Hopefully that makes sense. Does it make sense? Yes, it does. It makes sense. Now, let's say this now. You like the other example. So you have this. Which region? Say is enclosed no longer by this, by x equal to y squared. Meaning it will now be this. By what? X equal to 3, meaning this. By what? By the x-axis. Or simply the line y equal to 0. Then it means you are either talking about this region or you are talking about this region. But because the two regions are what? Symmetrical, then it doesn't matter which one you are going to spin. It doesn't matter which one you are going to rotate. The final answer at the end will be the same. So let us use this one then. You get it. Then from there, what? We are now rotate it. We are now going to spin it. So rotate it by, let's clear this. Rotate it by the x-axis. Don't forget, this x-axis is part of those steps that enclose this. And now, what is the question? The question is, find the volume of the solid of the resulting revolution. How far you? Question still remains, find the volume of the solid of the resulting, object. So what do you do now to find the volume of the solid formed this? Now, what you do is what? You can just cut those discs, but don't forget, you cut perpendicular to the center so that you can get what? Similar disc. Because if you don't cut perpendicular to the center, somebody can cut like this, cut. There from there, they are not going to look the same. Therefore, you cannot say the one that you have is a representative of all the others. The one that you have represent all the others, while the one that you have is not similar to the others, or it's not similar to some. Because what we're saying here is like you cut one, you find its volume, you cut another one with the same thickness, you find its volume, cut another one, find its volume, cut another one, find its volume. Depending on how many you have cut, from there, what it will be the ultimate, the total volume now. It will be the sum of the volumes of all the discs. It will be the sum of the volumes of all those discs, depending on how many you arrived at. So instead of doing this, then the formula results will be V equal to, you find the area, that is the volume of that one. Then from there, you let it run from this, the lower limit, up to that, and then you are done. So what will be the answer here? V equal to how much? It will be pi. Why pi? Because that disk that you cut, it will have a secular base. It will have a secular base. Therefore, it will be pi r squared. And you say integral what? Then you look at the thickness. If you cut it like this, because it must be perpendicular to the center. So what will be the thickness now? Is it a vertical line? That is a vertical distance? Or is it a horizontal distance? If you cut perpendicular.
Horizontal.
You tell us. Anybody? It will have what?
Horizontal thickness.
It will be a horizontal distance, meaning it will not be just x here minus x here. Therefore, it will not be dx. Therefore, everything now it will be in terms of x. Then this, it will now be, this region runs from where x is how much up to where x is how much. That is this region now. This region that we are spinning is enclosed between which two vertical lines? That is, it starts where x is how much. Where does it start? It starts here. And what is x here? X is 0. And it will continue until the last x here. What is the last x here? X is 3. Then from there next, it will not be the radius now. The radius of this, it will be the distance from here now, the distance from here up to here. It will be the distance from here up to here, which is now a vertical distance, which means it will now be what is y here minus y here. It doesn't matter whether you cut here or you cut here or you cut here. It will still be what? Y will be on this graph. Therefore, you come here and make y the subject of the formula because that y comes from here, meaning that y comes from here. Any y in here, you solve for y. It will be y is equal to the square root of x. Therefore, the radius, it will now be the distance from here up to here, which is now what? The square root of x minus 0. That is r. Because it will now be r squared. Then it will now be the square root of x all squared. Or you can just say minus 0. No. Say minus 0 here, it will be minus 0 here inside. Because this is r. So, but because it's minus 0, we don't even talk about it. But you must know that generally is there. Then from there, you are good to go. Because from here is just what? Simple integration. You have to square this first. You have to square this, and then it will be from 0 to 3 square. Then you integrate x. Then it will give you x squared over 2. Unless if your problem is what? This part, because from here you must now integrate. And integrating this part, it can be simple integration like this, or to integrate this, you may need any of those integral techniques. Maybe to integrate this, you will use what? By parts, or maybe you will use what? Any of these, the general power rule. You use any integral technique that you learned earlier with Mr. Kone. Hopefully that makes sense. So meaning you must now go back and revise those integral techniques. That is why here we're talking about what? The applications of integration. Meaning you must come with your integral knowledge. Does it make sense? Yes, it does. Now, let's take this further, because that is what mathematics is all about. Understand the basic. Once you understand the basics, then we can now keep on extending it. But if you don't understand, forget about when we are going to extend now. Let's say you take the very same region. Take the very same region, enclosed by this and this. And now you are now going to rotate it by a line that is not here. You are not going to rotate it by this line. You are not going to rotate it by this line. You are going to rotate it by a line which doesn't form the boundaries of that. Say you are rotated by y equal to minus 2. Where is the line equal to minus 2? It's somewhere here. Somewhere here. Y equal to minus 2. This is, remember, this is the x-axis. This is the x-axis. And below it, we have got minus 1, minus 1.5, and we have got minus 2 here. Then you are still taking this region. You are now spinning it by this straight line now. You see that? Now, this now is no longer part of this, of the boundaries. The question now is, how do you still calculate the volume of that revolution? The idea is still the same. The only difference is what? When you still cut perpendicular, this method that we are dealing with, there is another method, but we're still sticking to the same method. This method of using disk, you still cut those discs perpendicular to the center. The center, which is that line. Good. Now you are still going to cut like this. You are still going to cut like this. The only difference now is what? The resulting solid of revolution, it will now have a hole inside. It will now look like a bowel now. Hopefully that makes sense. It will now look like something like this. Hopefully that makes sense. It's no longer going to be completely closed like this one. This one is completely closed. This one is not completely closed. They say hole here. They say hole here. They say hole here. And right here is the center. This is the center. This marker is a center. There from there you have got what? You can talk of two radius now. Two radius. The one where from where? The one from the center to the inner solid of revolution, which we call it the inner radius. Then what about the other one? From the center to the outer now. Hopefully this makes sense. If you cut now, you are not going to cut, you are not going to get a solid slice. It will be, yes, it's still in the case of a bread, you will still have a slice. But now with this one, you are going to have a slice that is got a hole in it. A hole in it. A hole created because what? Because this one that is the center is not part of this. Does it make sense? Precious? Yes, it does. It makes sense. It makes sense. Now, the formula is still the same. We just have to modify it. Although, in fact, this one that we are going to write is more general than the one that we started with. It will still have pi good, the integral of this, good to go. You cut. What will be the thickness? It will be a horizontal line, meaning it will be dx, because it's a horizontal line. And then from there, what about the radius? As we have said, we have got two radius, meaning it will not be two radii now. One, it will be from here. One, it will be from here, from the right up to the center. And it's a vertical line, meaning it will be y here. And what is y? We know it because it comes from this. Therefore, you have to come here, make y the subject of the formula as we did. Therefore, it will be the square root of x minus y here. That will be the outer radius. This is the outer radius, meaning it will now be the square root of x minus -2, meaning it will be plus 2, because it will be minus -2, which is, then it will be plus 1. Then you square it. This is the outer radius. Then you say minus the inner radius. And what is the inner radius now? You can't say you don't know, ne? The inner radius, it will not be from here up to here. Can we use another color? Yes, it will not be from here up to here. That will be the inner radius. And it's a vertical line. Therefore, it will be y here minus y here. And what is y here? It doesn't matter. Y here minus y here, or y here minus y here, or y here minus y here, or y here minus y here, y here minus y. It doesn't matter where. So it will not be y here, which is 0. minus negative 2. Y here, which is 0, then it will be 0 minus negative 2. So which is how much? Which is just 2. But don't forget, you square it. Then from there, you remove the brackets and you integrate. In general, from there, you will now be saying what? This now region. Remember, we have spin this region. Start where x is how much up to where x is how much. That is, it's enclosed between which two vertical lines, 0 up to 3. Remember, we have said this is 3. That is 3. Then you just remove the brackets here. You integrate, and then that's all. That's all. It's finished. It will just be pi the integral from 0 to 3. Then you square this. It will give you what? Say 3 plus what? 4, the square root of x minus 4, then dx. If you square this, it will give you what? It will give you, no, not 3 here. What did I write here? Or what did we write? It will be x, né? Not 3, it will be x. It will be x this, then plus 4. And then this side is just minus 4. That's right, it will be this. This is this. And this is this. Then you remove brackets. And when you remove brackets, this falls off. Then you are now integrating this. Do you understand it, Lerato? Marco?
Yes, sir.
That is good. Anybody? Then you integrate this. Then you are done. Finished. You are done. Finished. That's all. Now, let us not go far. Let us play around with this. Say you take the very same region. Leave this out. Take the very same region. Enclosed by the very same curves. Now, you spin it now. Let's say you spin it by this straight line, x equal to 4. You spin it by the line x equal to 4. Then you look at this. X is equal to 4 is not part of the curves that enclose your region. Therefore, you're going to have what? That is small r. It's unlike if you have this. If you have something like this. If you have this. And you spin it by this. Spin it by this. Are you going to have small r? No, you're not going to have small r. But if you insist and say we're going to have small r, there's no problem. That small r, it will be 0. That is why we're not even talking about it. If you hear, but generally, our formula is this. V equal to pi, the integral of r squared minus r squared. There from there, it will either be dx or dy. Where this is the outer radius. And this one is what is called the inner radius. Hopefully that makes sense. But in this case, do we have the inner radius? No, we are not going to have the inner radius because you are going to have something that is solid like this. Therefore, this falls off. But if you take this region and spin it by something that is outside this region, spin it by this vertical line, say x equal to minus 3. This line, x equal to minus 3. Then this small r here won't disappear because it's not 0. The small r, it will be from here to here. That is the small r. And because it's a horizontal distance, it's a horizontal distance. Therefore, it will be r here. No, not r. It will be, because it's a horizontal distance, it will be x here minus x here. X here minus x here, which is 0 minus -3, which is 3. And what about capital R? Capital R is this distance from the outer, meaning from here now up to here. And what is R and what is X here? Then you go to the equation of this. You make X the subject of the formula, because it can be X here or X here or X here, but the fact is it must be X on this graph. Therefore, it would now be arbitrary X, not arbitrary X, because it's X on exactly this. Therefore, it must be, you take this equation, you make X the subject of the formula. Then you say subtract X here. Hopefully that makes sense. Or you can spin it by any line. You can spin it by this line. In this case, what will be the inner radius? If you spin it by this line, you take this region and you spin it by this line. So then what will be small r and what will be capital R? What will be small r? Tell us. What will be small r? Small r, Sipo? Unless if you have just logged in, then you went to buy Goda. Sipo, what is small r? So what is small r here? You are spinning it by this line. What is small r? Okay, Sipo is still buying Goda there. Small r, it will be this distance. That is small r. It will be x here, which is 2. Let us write it 2 minus x here. And what is x here? You take this, you make x the subject of the formula. We have said that this is y equal to x squared. Then we make x the subject of the formula. Therefore, it will be the square root of y. That's good. That will be small r. And what about capital R? It will now be this distance now. That will be capital R. That is capital R. Which is x here, which is 2, minus x here, which is 0. Therefore, capital R. But don't forget, in that formula, you must take square, you must take the difference. It will now be v equal to pi integral of, don't forget, minus r squared. Don't forget that. So then what is r squared? R is 2, therefore it will be 2 squared. What about this one? This one, it will be 2 minus the square root of y, what? Squared. Don't forget, you cut like this because the center is vertical. The center is a vertical line. Therefore, you were cutting this way. Then you cut this and you take it out. You cut, then you take that thing out. Then the thickness, it will be dy. Because you were cutting horizontally. Therefore, good. Now from there, it will now be this region that we are spinning. It's enclosed between which two horizontal line runs from where y is equal to 0 until what is y here? We have said y is equal to 2. Then you square 2, it becomes 4 minus in brackets. You remove the brackets here, then it will give you a nice integrand. Then you are good. We'll do it. Any question? No question. Are we ready for the next approach? That is the next formula. Because if you understand this one, then the next approach, it will still be what? It will be straightforward. It will be very simple. Why? Looking at the two methods, because sometimes you see what? Those two methods, you may find that no, they are all over the same degree. I'm not sure whether the same degree of difficulty or the same degree of simplicity. I don't know. And in some cases, you find that this method here is more complicated than the other one. And in some instances, you find that what? There is only one method that will work for that problem. Therefore, it's very important to know those two methods. Knowing, I mean, even what? Differentiating between them, because in some instances, you'll find that students, they are confusing these methods. You find that instead of, they're just complicating them, not complicating them, confusing them. They take one element of this method, they use it in the other method, and all what we can guarantee you is what? You will never come back. Once you mix all the ingredients of these two methods, you are out. Out for how long? Forever. You will never come back. So make sure that you understand, and that is why we spend a lot of time on just one method. Now from there, we can now talk about the other method now. Does it make sense? Yes, it does. What we did is what we call the shower method. The shower method and the disk method is just the same thing. It's just that the disk is a specialized kind of the shower method. Remember, we call it the shower method. We call it the shower method, where we are using disk, where you cut your disk perpendicular to the center. It's called the shower method. But if the small r is not there, if the small r is not there, then we call it the disk method. This is now called the disk method. But if the inner r is not 0, then we call it the shower method. Hopefully that makes sense. Why call it the shower method? No, you know it. Do you know what is called? I'm not sure about. It's a shower. When you cut this, it resembles what is called a what? A shower. What is a shower? Do I have something that resembles? It's just a disc, but with a hole inside. Hopefully that makes sense. Then you cut it perpendicular. Okay. Now the other method is what is called the shell method. The shell. The shell. That is the shell method. What about it is? This one, instead of cutting the disc perpendicular to the center, you use the outer layer or the outer layers. Some people, they say what? Hopefully you know what we mean by peel. You peel a banana, you peel an apple, or you peel whatever. You peel tomato, not tomato, potato, or whatever. You peel it potato. It will be like this. It's a solid of revolution. How do you do it? Now you cut this. Cut here, somewhere here. You cut here. Just cut. Then you cut, you cut. Does it make sense? Just a bit, a razor or whatever. Just like peeling potatoes. Just a bit here, cut here, you cut, you cut. Thereafter, then you pull it. You pull it, you pull it, you pull it, you pull it, you pull it until where you have started. Hopefully that makes sense. You can even use a banana, it will be better, that one. Or even, yes, potato, you boil it. There from there, you just cut a bit here. Cut, then you pull, you pull, you pull, you pull, you pull, you pull. There from there, what? Somebody can do here, somebody can do here, somebody can do here. You can do anyway. That is, you have this region. And then the next thing is what here? Now you just cut here, you pull here, somewhere here. Then from there, cut, say yes here, cut. Then from there, you pull. You pull, you pull, you pull, you pull, because it will be like this. You are pulling, you are pulling, you are pulling. Then when you take this outer layer and flatten it on a table or whatever, you are going to get something like this. A rectangle. So a shell method use rectangles obtained from what? Cutting the outer surface or the outer layer. When you flatten this after, you get a rectangle like this. Hopefully that makes sense. Then how do you cut? Because with the disc, you cut perpendicular to the center. Now, what about your rectangles? You cut them parallel to the center. So if it is like this, so what is the center? The center is a vertical line. So how do you start cutting? Because the center is a vertical line, then you are going to start cutting vertically. Then from there, a bit here so that you can pull. So if you have got something like this, which is horizontal, how do you cut? Don't forget, you cut parallel to the center, because you have got a parallel horizontal center, you have got a horizontal center, therefore you're going to cut parallel, meaning you are going to cut like this a bit, then you pull, you pull, you pull. Then you are going to get something complete, then you flatten it, then that will give you a rectangle. So then what is the formula then in that case? What is the formula? The formula will now be 2 pi. The 2 is inherent in that formula. Then you say the integral of what then? The integral of what? Then you say, okay, let's say I cut here. Say I start here. I say here, cut here. I start here. I cut here. Cut here. Say somewhere here. I cut here. Doesn't matter where. You cut here. Then it will now be the distance from here to here. We are not saying the distance from here to here. Hopefully you can see. Okay, let us make a very big diagram so that everybody can see, including myself. You have something like this. And if you can't see, please tell us. You have something like this, something like this. This is the region. Where do you cut? Say you cut here. Let me just make it big so that we can see. Now, it will now be the distance from here to here. Use another color, the distance from here to here. So then it will now be V equal to 2 pi, the integral of what now? It will now be the distance from here to here. We're not saying the distance from the graph. We're saying the distance from any here, the distance from any here. Because somebody can cut here, somebody can cut here, somebody can cut here. So it will be the distance from here to here, or from here to here, or from here to here. And this is just what? Any point inside. Therefore, you cannot say, I will come here and make X the subject of the formula. No, it will not be from here to here. And it's a horizontal line. Therefore, here is just an arbitrary X because it's a horizontal line. It will not be X minus X here. And what is X here? Just an arbitrary X. Therefore, it will be X minus 0, which is now X. Then you multiply it by what? You multiply it by, remember, you now have something like this. Because you cut here and then you pulled. So now, what is this now? You now multiply it by this. This distance from here to here, or here, which is from here to here now. Hopefully that makes sense. Which is now from here to here, or from here to here. Before you go far, we go far. Does it make sense, George? Heinrich, does it make sense? Yes, it does. Silence means concern. It does. Now, what is the distance from here to here then? The distance from here to here, or the distance from here to here, or the distance from here to here. And here we're talking about from this F, from this F up to this F. And this is a vertical distance. Where does it start? It starts exactly on this curve, on this graph. You are going to end exactly on this graph. And it's a vertical distance. Therefore, it will be y here. And what is y here? Y at any point on this, y at any here is how much? Is y equal to 2. We know it. Therefore, it will be 2 minus. And what is y here? Y here or y here or y here? Because it's y on this. It's y here. It's y on this. Therefore, you must go and take the equation of this and make y the subject of the formula. And what is the equation of this? The equation of this, we have said y is equal to x squared. Therefore, it will be 2 minus x squared. Then it will be 2 minus x squared. Then you, with respect to x. Then this region is enclosed by which two vertical? Because everything must now be in terms of x. This region is enclosed by which two vertical line? This runs from where x is how much? From where x is until where x is here. And what is this? Is the point of intersection of the curves y equal to 2 and y equal to x squared. This is where y equal to 2 and y equal to x squared intersect. Therefore, it will just be what? Simultaneous equation. Y equal to 2 and y equal to x. This is obvious. You replace what? Y by 2. Y is 2. You replace y here by what? Y here by 2. Now from there you calculate x. That's all. Is it you calculate x? No, you can just because we know, yes, you can just calculate x. What is x? X, it will not be what? Plus or minus the square root of
2.
Plus or minus the square root of 2, ne? Yes. Meaning x here is plus the square root of 2, because don't forget, they intersect again here, where x is how much? Minus the square root of 2. But here we are interested in this one. Therefore, it will be up to the square root of 2. Then you solve this. You integrate this. Then you get the answer. Finish. That's all. Then you can, don't forget, you can solve the very same problem using the disk method. If you're using the disk method, it will be y equal to pi the integral of what? If you're using the disk method. If you're using the disk method, don't forget now, because you're using the disk method or you're using the shower method, you are going to carry those disks perpendicular to the center. This is the center. You are no longer going to cut parallel to the center. You are now going to cut perpendicular to the center. Hopefully that makes sense. Then if you take that disk out, the disk, it will have a vertical thickness. Therefore, it will be the difference between the values of y. There's got a vertical thickness. Therefore, it will be dy. Then you check it out. The region, where does it start? It's enclosed by two horizontal lines. Y equal to 0. And what is y here? Y equal to 2. Then from there, you're now going to come back here and say, okay, I've cut here, I've cut here. There is no inner radius, or the inner radius is 0. Therefore, it will just be what? The distance from here to here, which is a horizontal distance. Therefore, it will be x here minus x here, because it's a horizontal distance. And what is x here? Is x at this. And we know y is equal to x squared. So what is x at any point here? It will be the square root of y. Therefore, it will be the square root of y squared. It will be this. Then from there, you compare the two. Which one will be simple? Which one will be difficult? No, I can't say difficult, because they are all simple. The only difference is what? The relativity there. They are all simple. Which one will be simple? That is the disk method, because you just have to remove this and then. But this one, it will still what? This and this, they're going to give you the same answers. They're going to give you the same answers. It's just that this one, it will be a little bit, it will add a little bit of hard work. But don't forget, marks are awarded according to the shortest method. So therefore, you must beforehand see which method here will simplify this. Is it going to be the disk method, or is it going to be the shell method? But in some problems, finding that the shell method is better than it is. And in fact, in some, you find that the shell method is the only method that will work. The disk method won't work. That makes sense. Let's say another one. Say you take the very same region. Because this is mathematics. With mathematics, it's nice. Why? Because you can play around with the same example using changing, so that at the end you understand. Say you are rotating by the line x equal to -1. Take the very same region. You are rotating it by the line x equal to -1. The question is, can you set up that integral, that integration formula? Can you set it? Let us just set it. How many minutes do you think you will need, Mahatu, just to set that? Not to calculate until the final answer, just to set the formula for what the washer, come and set the formula for the shell. Then you will go and do it after the class, just for practice purpose. Can we start, or must I leave it for you? Let's say, let us start. Say the shell method. The shell method. Let's start with the shell method. Don't forget that the shell, it uses the outer layers. We peel But then how do you cut? You cut parallel to the center with the shell. Then it will be V equal to 2 pi, the integral of what? Then you cut parallel. Still, this is the center. Therefore, you're going to cut like this. You're going to cut like this because it must be parallel. Then it must now be what? This distance now, which is a horizontal distance. Ah, this is nice, man. Because it's a horizontal distance, then it will be x here minus x here. X here is an arbitrary x because we are not saying x here. We are saying x at any point here. Not necessarily here. It can be here, it can be here, it can be here. Therefore, it will just be an arbitrary x. Therefore, it will be x minus -1, which will now be x plus 1, multiplied by what? Multiplied by the height of this. The height of this. The height of this. And it's a perpendicular. No, it's a vertical height. It's a vertical height from here up to
a vertical height. Why is
this is 2, y here is 2, until y on the graph. It will be y on this graph, which is 2, until y on this graph. Therefore, it will be 2 minus. What is y here? What is y here? Is y on this? Is y here? Is y at a graph? No, I will pretend I didn't hear that. I will pretend I didn't. I'm giving you a second chance. It's not 0. Y is 0 on the x-axis. On the x-axis, yes, it's 0. But we are not saying y here. We are saying either y here. It will depend because somebody can cut here. Somebody can cut here. Don't forget, somebody can cut here. Somebody can cut here. So it will be y here. It will still be 2. And what is y here? Is it 0? No. What is it?
X.
X squared.
You make it.
It's x squared because it's y on this graph. Y at any point on this graph. Y here is, it will depend on x. Y here on this graph. It will depend on x. Therefore, y at any point here is x squared because this is given by y is equal to x squared. Y is x squared at any point. Y is x squared. Including here. If you cut here, y here is x squared. If you cut here, y here is x squared. Is dependent on x. Therefore, it will be x squared. Then you can see that, oh, everything is in terms of x. Then you integrate with respect to x. Then from where to where? This is x. You look at the region, this region runs from where x is how much up to where x is how much. Start where x is 0. Until where x, the last x, the biggest x is here. Remember, there are many x here. There are many x, infinitely many x. Many x. There's x here. There's x here. There's x here, but you cannot use this because there are some other rich values of x this side. The last x is this one. The last x is this one. You can't say the last x is here. No, be serious. You can't say the last x is here. No, be serious. The last x is this one. That is the point of intersection. The point of intersection of this, which is y equal to x squared. And what? This one, the point of intersection of this, which is y equal to x squared, and this, which is y equal to 2. Then that is simultaneous equation. We are looking for x. Then we just come here. Y is 2. Then you replace y here by 2. Y here by 2. Then you solve x. It will give you plus or minus the square root of 2. plus the square root of 2 here. Then this side, don't forget, this line y equal to 2 and this, they will intersect twice. They will intersect here, where x is positive, that is the square root of 2. They will then intersect here again, where x is negative, which is minus the square root of 2. Therefore, it will be from 0 to the square root of 2. That is the shell method. That is the shell method. What about a disk method? Y equal to pi what? Don't forget, with the shower, you cut perpendicular to your center. You cut perpendicular to your center. Don't forget, let me take this out. You cut perpendicular to your center. This is your region. And this is the axis of rotation. X equal to -1. Cut perpendicular to the center. This is the center. Therefore, you're going to cut like this. And take this out. Take this out. Then what about its thickness? Is it a vertical distance or is it a horizontal distance? It's a vertical distance because you're going to cut this like this. So therefore, it will not be what? dy. Vertical distance is thickness. If you want to measure it, it will be this. Hopefully that makes sense. Then from there, what now? Are we going to have the inner arc? Yes, because what? Because this axis of rotation, this line, x is equal to -1. It's not one of the boundaries of this region. X equal to -1 is not one of the boundaries of this region. Therefore, this space here, this space, it will give you a hole inside your solid of revolution. So when you cut, there will be a hole. It's not just a solid disk. It will be, yes, it's still a disk, but then with some hole inside. Like if you take this, and cut it here, take this and cut it here, cut. Then when you take this, then there is this hole inside. So therefore, the small r is there. Then it will be capital R. Capital R is the distance from here to here. Capital R is the distance from here up to here. Then you can see, oh, this is a horizontal distance. Therefore, it will be x here, which is x on the graph, minus x until it is. It will be x here minus x here. That is x here minus x here. And what is x here? Is x on this. Therefore, you must come and take this and make x the subject of the formula. Take the equation here and make x the subject of the formula. Don't forget, this is y equal to x squared. Make x the subject of the formula, it will be the square root of y. Then it will be the square root of y squared minus the inner radius. What is the inner radius? The inner radius is this. That is the inner radius. That is this distance. This distance is the inner radius. It must not be what? X here. What is x here? Is 0 because it's on the y-axis. 0 minus x here. And what is x here? It's
-1.
therefore it will be 0 minus 1, which is 1. Therefore it will be 1 squared. Now from there you are just going to say, okay, this region now is enclosed by which two horizontal lines? This region is enclosed by which two horizontal lines? What is the smallest value of y in this region? In here, what is the smallest value of y? Is how much? 0. Yes, Andre?
A quick one, sir. The bigger radius, isn't it supposed to be square root of y minus -1?
Okay. Thank you very much. Ne? Thank you very much. You see? Now we are together now. Thank you. Alerato, no. This is wrong, ne? Yes, because it must be the distance from here up to here. So x here is the square root of y. Then it must be the square root of y minus -1. Thank you very much. Then it will be what? It will be this. It will be the square root of y minus 1 all squared. It will be this. Thank you very much. It will be this. Then from there, good. From 0 up to what? What is this y here? In this region now. Talking about this region. What is the greatest value of y? The biggest value of y here is 2. It will be 2. Then you look at this. Which one will be simple to evaluate? I don't know. Then you good to go. Any question? Yes, Andre?
I just want to understand on the shell method there. So the shell method, we don't have the smaller r, or we don't consider the smaller r on the shell method.
No, we don't have. Remember what we mean by small r and big R, because you see small r. What do we mean by the small r and the big R? We mean what? Because with the shell method, remember we are using rectangles. We are using rectangles. So we will say the distance from where you cut. Let us clear this again. So this is that center. And this is your region. And we are using the shell method, which at the end you are going to get rectangles. You're going to get rectangles. Let us stress that we are going to get the rectangles. How do you cut it? You can just cut here. Or somebody can come and cut here. It doesn't matter. Then from there, we are now going to say the distance from here to here. What is the distance from here to here? It's not the distance from the graph. It's just arbitrary x. It will be x here minus x here, or x here minus x here, or x here minus x, or x here minus x here. And we mustn't get this different results. Arbitrary. You cut here, somebody cut here, somebody cut here, somebody cut here. But at the end, whatever we're going to have, it will not be representative of everything. It will be a representative of all rectangles. Remember this. Outside is covered by rectangles. If you cut, pull out, cut somewhere, pull out, cut somewhere, pull out, cut somewhere nicely, pull out. If you put back all those rectangles, they must still cover this. Like when you cut the disc. If you take a loaf and cut slices, it must be similar slices because they must have the same thickness. When you put all those slices back, they must still give you what? The same bread. Even if you use the rectangles, if you put them back, they must still completely cover this. But don't forget, that's right. Then it will now be from here to here. And that is this, x plus 1. Because after cutting, then when you flatten it, say you use it, you cut from here to here. From here to here. Then when you flatten it, it will give you something like this. remember it's from here to here. It will give you something like this, something like this. So then from here to here, it will not be what? Like from here to here now. It will not be like from here to here. If somebody cut something like this, then his rectangles, they will not be something like this. His rectangles will not be, it will not have this. Therefore, it must not be from here up to here. If you cut this, it will not be from here to here, from here to here. If you cut here, good. Then this now is now this part from here to here. It's like now the height of your rectangle. Then from there you are done. Whether you have used the shell or whether you have used the washer, don't forget the disc is still the washer. It's just that the disc is the washer with small r equal to 0. And small r, it will be equal to 0 if your center of revolution, the center, that vertical line, no, that line that you use to spin, it was part of the boundaries of your region. Unlike here, this is not part of the this, the center is not part of the curves that enclose your region. Therefore, here the small r is not going to be 0 if you are using the disc method or the washer method. The small r is not going to be 0. The small r is 1. The small r is this, is 1. But if you move this, if you move this, if you move this, move this, move this until this is exactly here, then the small r1 will fall off. It will fall off. Hopefully that makes sense. Now, as we have said, to integrate this, because here you can have this, you can have this one here, say this, y equal to what? Say y equal to what? Whatever, say cos x. The region is enclosed by y equal to k cos x, x equal to how much? Say pi over what? Say pi over 4. Then you have to sketch this. Y equal to cos x, we know is this. So on and so forth. And where here we know is pi over 2. Now they say here, but now it's enclosed by this and say what? The x-axis and the y-axis. It's enclosed by this. So which region are we talking about here? One fence, it must be this, meaning it will be inside here, inside. Now from there, x 4 somewhere here, or let's say x equal to pi over 2, because here we're just talking about the conceptual understanding. Say it will not be this, meaning that from there the x-axis, that is this. Therefore, the region that we're talking about is this one. We're talking about this region. It's enclosed by this. We're talking about this region. And what is important now is rotated by what? You see, very important, which will not be the center now. So it's rotated by what? By the y-axis. The y-axis, which is part of the boundaries. So what would be the volume of the solid of revolution? It will simply be what? Now let's pause here and say, Which method here do you think it will work better? Is it a shell? Or is it a washer? You must see beforehand which method it will be very effective. Which method here? Let's talk. Which method? Sipo? Which method, Brenda?
I think what do you call it? The washer.
Is it a washer?
I see. Top and wood.
No, you don't know.
I'm not sure.
Fortunately, it's not in the exam. Fortunately, it's not in the exam, Brenda. Fortunately, it's not in the exam.
I'll use the one with the 2 pi.
Come again?
I'll use the one with 2 pi. So that is the shell one. I'll use the shell.
Yeah, but then did you try to construct it just to visualize it? Because the one with 2 pi, then we are now going to cut parallel to this. The one with with 2 pi, we are going to cut parallel. Then you are going to cut like this, because it must be parallel. Therefore, it will be this distance, which will be x, because it will be x here minus x here is 0, is x. Now, what about the height? What about the height? It will now be y here minus y here. And y here is cos x. Therefore, definitely, the washer method, no. The shell method is going to work better. The shell method is going to work better, the shell method. We can just write the formula. It will now be what? V equal to 2 pi integral of what? This is x multiplied by what? Say cos x dx. Now the question is, how do you integrate this? You can say it's x cos x. Then which method now? Which technique are we going to need integrating this? X cos x. It will simply be what? Which technique? Where x runs from 0 up to pi over 2. Which method integrating this? X cos x. It will be by parts. It's by parts. Yes, it's by parts. It's by parts. Remember, with by parts, generally, with by parts, you let be something that you can differentiate, and dv be something that you can integrate straight away. Hopefully that makes sense. You did it with Kone. Generally, choose u be something that you can differentiate, because from you must now find du dx. And from dv, you must now integrate. Therefore, when you say something is dv, then from that, then you must integrate and get v. And when you substitute back your new integrand, it mustn't be more complicated than the initial integrand. Say here, which one can we choose as u, and which one can we choose as dv? Which one? Let u be what?
Bx.
Bx. And dv be what? Cos x dx. Remember, this is u. This is out. Is u. This is out. Is u. This is out. Is u. Then whatever is left here, it will be your dv, which is cos x dx. And from here, you must now differentiate. Therefore, it will be du over dx is equal to 1. Therefore, du is is dx is u. And from here now, you must now integrate immediately. So which will give you v equal to how much? Sine x. And when you come back here and substitute, generally, your new integrand, remember this is our integrand, is x cos x. The new integrand, it mustn't be more complicated than x cos x. Instead of what? Now you can now substitute now. Substitute. Remember, this is how much here? U dv. Instead of x, you write u. Instead of this cos x dx, we have said is d. Then from there, what is this? Is how much? Is uv minus what? V du. And this is our new integrand, which mustn't be.
You can see the full screen. Go up a little bit. The du equals dx is not.
Oh, okay, let me write it this side so that I can use big letters. What happened to my markers? Okay, it's here. Okay, let me write it this side. It will not be what? It will not be, instead of x, it's u. So it will not be what? Du dv. Can you see now?
Yes, I can.
Yes.
That's right.
But I was talking
Then,
about the bottom, the bottom part after let ux.
okay, let me do this. Let me do this.
Yes.
Okay, then what is this? Then let me go to, okay, then there is no problem. And what is this? Integration by parts. This, the integral of u dv, so much is uv minus what? V du. Hopefully you can still see it. Now, we were saying, because now this is going to be your new integrand, this. We're saying it mustn't be more complicated than x cos x. Then you substitute, make substitution. What is uv? U is x. And what is v? V is sine x from here. U is x and v is sine x. Then it will be minus what? What is v? V is sine x. V is sine x. V is sine x. And what is du? Du is dx. Du is dx. Dx. And what is our new now? So now instead of integrating x cos x, this product, instead of integrating x cos x, we're now going to integrate what? Sin x. That is the whole purpose of integration by parts. But don't forget what? The 2 pi here, and don't forget what? The limits. You still have what? 2 pi. Don't forget, 2 pi is still here. It will be 2 pi in brackets, what? There is still 2 pi here. Don't forget it. 2 pi here. And the limits is still what? From the limits here, everything. Then it will not be what? At the end here, 2 pi. Hopefully you can still see what? X sine x. And what is the integral of this? It will be plus cos x. From where? From 0 up to pi over, up to 2 pi over 2. Hopefully you can see. Because now from there you just substitute. But don't forget. Come again.
We can see.
Which one? At the bottom or?
No, not at the bottom, on the side.
Okay, let me.
Yeah, it's fine now, sir.
Okay. But don't forget, you said your calculator correctly. The units here, we're not saying from 0 degrees. We are not saying up to pi over 2 degrees. We are saying from 0 to pi over 2, meaning your calculator must be in radians. Otherwise, you're going to get it completely wrong. That's good. Hopefully that makes sense. But now, let us look at the very same problem. Say using what? The disk method.
Disk
The
method.
very same problem. Yes, any question? Using the disk method.
No, sir.
Are you all right? Okay, let's say using the disk method. Just to play around with this. Just to play around with this. But remember, you can only get that, expertise if you do mainly. With the disk method, it will be V equal, there is no 2. Unless if, let's say you are spinning this. They say spin everything. Spin everything, spin everything. Then you want to use the disk method. Say you are spinning it by whatever. Say you are spinning it by this line, x equal to, say 2, and then this is 1 here. X here is 1. X here is 1. Then you are spinning it by the whole region. Then you want to use the disk method. Then instead of using the whole region, you can only use what? Just one part. You see. But therefore, in that formula, you have to include 2. Because if they say use the whole region and you are only using half of it, therefore your answer, you must know that in fact is half of the final answer. Therefore, you must take that answer, multiply it by 2 to get the final answer. Hopefully that makes sense. I mean, if you are using the disk, if you are using the shell, you do the same thing. Hopefully that makes sense. Okay, now coming back here, pi equal to how much? We want to use the disk method. We are spinning it by this. Don't forget. Therefore, you must cut what? Perpendicular to the center. Therefore, you must cut it this way. You must cut it this way. Cut it this way. Therefore, it must be x here minus x here. X here minus x here. X here minus x here. And what is x here? Then it means you must come here. Make x the subject of the formula. Making x the subject of the formula is going to be what? Inverse cos of y. It will not be inverse cos of y. Therefore, it will not be pi, the integral of what? It will not be inverse cos of y, what? Squared. You see. And then what? That is dy. From where y is how much? From where y is 0 up to what is y here? Is 1. Then you must now integrate this. And there's nobody, definitely, nobody's thinking of the power rule. Saying, oh, the integral of x squared with respect to x, it is just x exponent 3 over 3. Therefore, this will just be inverse cos of this. It will not be this, because some student may be thinking that, because of this, then it will just be what? Divided by, oh, that is what? 3 here and 3 here. Don't be thinking about it. Please don't even be thinking about it. You see, you see that now this is going to be tricky, because you must now find what? Inverse cos of y. Write it in that form. Inverse cos of y. Then from there, square it, which is going to be a lot of work. Square it, get an answer, then from there do it. You see. Therefore, here the shell is going to be much better. Okay, now coming back, I've even forgotten. I'm not even sure whether we should even look at this. There was this question. I was asked by your doctor that somebody asked this question. Somebody asked her this question, and she asked me to do it. They say there is a region enclosed by these two curves. Can you sketch it? The region enclosed by these two curves. Very fast. I'm just looking at the time here. It will be something like this, more or less. This is this. Y equal to x squared plus. Come again?
Cannot see the second equation.
This one.
Quickly on the screen. Go down a little bit.
Go down.
Oh no. Yes. Yes.
Can you see it now? Okay.
Yes.
Then from there, what? Can you draw this line? Good. Y here 4. And x here minus 4 over 3. Y here 5. Which region are we talking about here? Which region, Andre? Or am I pronouncing your name properly?
No, it's Adri.
You can see that. Come again?
It's Adri, but that line isn't supposed to be cutting through that curve.
Y equal to 5, Y equal to 4. It must be below. And I agree with you. Why? Because if you take these two, and find a point of intersection, you will find that it exists. So if you draw them like this, then there is no point of intersection. Therefore, there is no enclosed region. Because what is the point of intersection of these two? It will be 2x squared plus 5 equal to 3x plus 4. Then it will be 2x squared minus 3x, I guess, plus 1 equal to 0. Then you can see that, oh, it will not be 2x minus 1, x minus 1 equal to 0. Is it correct? Yes. Therefore, these two, they intersect at this. They intersect here. Therefore, if you sketch them like this, then you don't get it. I agree with you, Adri. This is wrong. That is my guess that frustrated that student. So this is wrong. The sketch is wrong. As you said, Adri, your graph must be something like this. That's right, 5 here. There's no problem. And then the other one, it must be exactly, okay? Let me just do it something like this. Good. Hopefully you can see. Then the other one, it must be exactly something like this. This is 4 and this is 5. This is 5. Then from there, we are talking about this region. Now from there, you can spin this region by whatever line. Whether it's a horizontal line or it's a vertical line, it shouldn't make any difference. Now, but let us continue. They say around you spin this around the x-axis. Question here is spin this, rotate this by the x-axis. Meaning you spin it by this. Which method it will work better? Is it the shell or the washer? Remember with the washer, cut your disc perpendicular to the center. With your washer, cut your rectangles parallel to the center. Let's say the disc, which is going to
Now,
become
this
the
shell.
washer. Which is going to become the washer. Why? Because this line is not part of this region. This line, the center, is not going to be part of this region. Or Brenda said the washer, it's no problem. With the washer, it will be 2 pi. With the washer, it will be 2 pi. Then we are going to use rectangles. Come again?
Isn't
Come
it
again?
isn't it the shell, the one for 2 pi? Then the disc is the same as the washer, the one for pi.
No, the washer, it has got a 2 pi. I'm sorry, the shell.
What the shell say?
Yeah, the
Yes.
shell has got a 2
Yeah.
pi.
Oh, yeah, thank you.
That's right. Or what did I say?
Because the disc is the same as the washer, then the shell is on
Okay.
its own,
Oh,
2 pi.
okay. Okay. I'm sorry. And then it means I mixed this up. Fortunately, I'm not writing the exam. Otherwise, I was not going to come back. So here we're using what? The shell in it, because they say 2 pi. Then because now 2 pi, therefore you are going to cut parallel. You're going to cut this. Then from there you're going to say, what is this distance? It's a vertical distance. Therefore, it will be y here minus y here. So what is y here? Y. What is y here? 0. Then multiplied by what? This now. And what is this? It's x here minus x here. It will be x here because it's on the parabola. Then it will be y equal to 2x squared plus 5. Then you make x here the subject of the formula. So make x the subject of the formula. It will be prime 5 here and 2. Therefore, x, it will now be what? Half the square root of, because prime this, it will now be y minus 5.
Minus
It's
5
good.
over
Now,
2.
divide both sides
square.
by 2. Good. Then the square root. Then
Square root,
it
yeah.
will now be what? The square root of this. All over 2. dy. Now from there you can just say white here. This is the shell. What about the washer? We're just trying to study this and say and look at which one will be better. What about the washer then? You are now going to cut this perpendicular to your center. That's right. Cut it. Then when you cut it out, it will now have what? A horizontal distance, the thickness. It will be horizontal. Then it will now be what? The distance from here to here. Capital R. What is y here? Is y on that straight line? Is here. Is y. This capital R is 3x plus 4. Therefore, it will now be what here? 3x plus 4 all squared. Minus what? This is small r. What is small r? It will be y here minus y here. It will be y here minus y here. And what is y here? It's only this, which is y, which is 2x squared plus 5. Therefore, it will be small r is 2x squared plus 5. Then it will be 2x squared plus 5 squared. Then dx. Then you look at this. It's enclosed between which two vertical lines? They start here. What is x here? It's half. Because we have said they intersected half and 1. And what is x here? 1. Then you just have to plug in the values of y here. X here is half. What about Y? You come and plug it here. X here is 1. What is Y? You come and plug it in here. Remember, finding the Y, you can use this straight line, which is Y equal to 3x plus 4, or you can use this one, which is Y equal to 2x squared plus 5. Then from there, you compare these two and say which one it will be simple. Obviously, I will go for what? For the washer. Because otherwise, then this, it will be what here? This one, it will be by parts. This one, it will be by parts. And this one, you just have to remove the squares.
Sorry, sir, can you move your camera there? I can't see the second equation. Yeah, thank you.
But the main question is, can you construct it? Can you construct it, Andre? Or is it code? This time, I don't remember you, Ethan, saying anything. Are you with us? I doubt.
Yeah, I'm still
Ethan.
here.
He's still here, Ethan. He has never said anything. Good. Any question? Whether you use this or this, at the end, we are going to arrive at the same answers. Otherwise, somebody somewhere is wrong. Just go and try it, or go and try. Take those examples in the book. Take those exercises in the book and look at which method they've used. And then try to use the other method and see whether you will arrive at the same answer as the one in the book or what. And if you do as many as you can, as you have said, then you will have an idea of which one here will work better, which one, so on, so that in the exam, you don't have to do trial and errors. You're wasting time, which we don't have in the exam. Remember, in the exam, it's not just about whether you know something. No, it's also about, can you write it within the stipulated time? Otherwise, if you only realize when you leave that no, I should have used this one. No, you don't have time to go back and say, no, I made a mistake. Can I have my script back? I made a mistake here. I know this. Okay, now I'm looking at the time here. Our time has elapsed. Then if nothing, then we can call it a day or a weekend, not a month. Any question? Do you have a question, Lerato? Going in 3, 2, 1, gone. Sipo, anybody? Jump, anybody? Nothing?
I think so. We're fine. Thank you.
I'm good, sir.
Okay, me, I'm good. Then I'm also good. So thank you. Next time, same place, same time. Good. Thank you very much. Please, dear guys, try to read forward. Try to read forward. What is the next topic? And try. We're not saying understand it. Just be familiar with. You mustn't hear them for the first time during their lesson. Just go through it. We're not saying understand them. No, just read. Just read like a WhatsApp. Because I'm old. Read it like a newspaper. You don't have to understand anything. Just read. So that when we talk about those, you mustn't be hearing for a concept for the first time. Thank you very much, and bye-bye. See you later.